Now that we are done with data exploration, let's move to the next stage of predictive modeling, which is model building. So what is model building? Model building is the process of creating a mathematical model which can learn from the past data and make predictions about the future as best as possible. Let us have a look at an example to understand this better. For example, a retail bank wants to know the default behavior of its credit card customers. And by default behavior, we mean that the credit card company wants to know the probability of a customer defaulting on his or her credit within the next 3 months. Now that the company is interested in probability, we know it will lie somewhere between 0 and 1. Now, assume for the moment that every customer has a 10% default rate initially. So what is the probability of default for each customer is 0.1. Now what do these predictive models do? These models move the probability towards one of the extremes based on the attributes from the history of the customer. So a person with a volatile income is more likely to default on his or her credit card. So the probability will be closer to 1. Whereas a person with a very good credit history for the last 10 years will have a very low chances of defaulting. So his or her probability will be closer to 0. Now we had a higher level overview of how predictive models work. We will dive into details later. Before that, let us have a look at the steps of model building. Model building comprises of mainly 3 steps. First is the algorithm selection. Second is training the model using the selected algorithm. And lastly, making the predictions using the trained model. Another step comes in addition to the last one, which is scoring the model, where we check the quality of the model built. Let us now talk about each of these steps in detail. In the first step of algorithm selection, we select the algorithm based on certain factors as depicted in this chart. So, first of all, if we have a dependent variable, then the problem becomes a supervised learning problem, otherwise an unsupervised one. We are going to restrict ourselves to supervised learning algorithms for now. Further, if our problem has a continuous type dependent variable, then it becomes a regression problem. Otherwise, it becomes a classification problem. Then we choose algorithms specific to regression and classification to solve our problem. Now once we have chosen the model, we move towards training the model, which is the process of learning relationship between independent and dependent variables. Let's look at an example. Suppose the red line is the learned relationship between age and credit limit. The learned relationship is of the form y is equal to 1.4904 multiplied by x minus 16.838. Now here y is the credit limit and x is the age. So credit limit is dependent on age, or in the terms, credit limit is a function of age. So now the question is, where can we use this equation? We can use this equation to estimate the credit limit of the people in the test dataset. So first of all, what is a test dataset? So generally, a dataset is divided into 2 parts, train and test. Using the train dataset, we train our model or learn the relationship between independent and dependent variables. It also represents the past data, whereas test data is one which does not have a dependent variable and is used to make predictions. It also represents the future data whose dependent variable is unknown. Now after training the model or learning the relationship, we move to the last step in model building, which is making predictions. We use the learned relationship to make predictions on the test data. So for example, our learned relationship between age and credit limit was a linear equation. So now, if we wish to predict the credit limit for a person of age 40, then we can simply put the value of x as 40 and get the credit limit as shown. Similarly, for a person of age 50. So this was how we can use the learned relationship for making predictions. Also, it should be kept in mind that we always make predictions on the test dataset and not on the training dataset to check the quality of our model, as making predictions on train may provide inaccurate and overly optimistic results. So this was all about the basics of model building. Thank you.